can use a chat to answer. So this exercise one is related to distance, displacement, speed, velocity, and acceleration. Chat is open. You can use the chat to answer. I'll solve each question from this exercise. So a sprinter runs 100-meter race in a straight line. The table shows the change in the speed for first 5 seconds. What is the average acceleration from 2 seconds to 3 seconds? What is the formula for acceleration? If you want to calculate acceleration, it is a change in velocity, which we can say the final velocity minus initial divided by time. So we want from 2 seconds to 3 seconds, this interval. So the final velocity is 5.7. The initial velocity for this time interval, that's equal to 4.1. And how much is the time interval? Because the time difference is there, 3 and 2. So the time interval is 1. So it is 5.7 minus 4.1 divided by 5.7 minus 4.1 divided by 1. So we'll get 1.6 divided by 1, or which is 1.6. And the unit of acceleration is meter per second square. So A will be the right answer. In question 2, student is finding the average speed of a bubble rising through a liquid. After 2 seconds, the bubble reaches point Q. So moving from point P to Q, first we'll find how much distance is there. Like this is 25.7. So this value is 25.7. And this one is 18.1, 18.3. So how much distance it cover? So we just subtract 25.7 minus 18.3.
7.4.
So 7.4, and so this distance is equal to 7.4, but the unit is in centimeter. And how much time it took moving from position P to position Q? It took 2 seconds. So it will be 7.4 divided by 2, which is equals to 3.7. So B will be the right answer. For any question, if you are not able to understand or you want me to repeat, you can just let me know in a chat, or you can use your mic. So I will explain that. Which distance time graph represent a body whose speed is decreasing? So a distance time graph, remember what the slope represent, the angle represent, the slope represent the speed of an object. Because it is a straight line, whenever it's a straight line, it means the speed is constant. These two graphs cannot be for distance. So B and D are totally wrong graphs. Because distance cannot decrease, it should be displacement graph which can decrease, but not the distance. From the starting position. So these two graphs are not represent. Even if it was a displacement graph, then also B and D were not answered because it's a straight line. So whenever it's a straight line, what it shows that is speed is constant. And here what happened, the angle with the x-axis is increasing. When you check the angle with x-axis, angle is increasing, it means the speed is increasing. But what about C? When you check the angle with x-axis, the angle with the x-axis represent or shows the speed of an object. So in the beginning, it is much steeper as compared to when the object moves. This angle is decreasing. So when distance time graph, the angle decrease, it means the speed is decreasing. And when the speed is decreasing, what we say, the object is decelerating. So C will be the right answer. Is it clear, this one?
Yes, sir.
Why isn't D the right? Because D is showing the angle is increasing. The angle with x-axis is increasing. It means the speed is increasing. When you check the angle with x-axis, this is the initial angle. When you draw another horizontal line, x-axis, So you can see the angle with x-axis is increasing. So if the angle is increasing, what it shows? It shows that the speed is increasing, because the slope or the angle for a distance time graph, the slope or the angle represent the speed of an object. Here the angle was constant, like all the points angle was same. That's why the speed was constant. Here also angle is same, speed is constant. Here angle is increasing, so speed is increasing. But for C, the angle with the horizontal line or x-axis, it's decreasing. That's why the speed is decreasing. So remember, distance time graph, the slope represents the speed of an object. Then an object at a constant speed for some time that begins to accelerate. Accelerate means like speed increases. So first, this is a horizontal line. When a distance time graph, it is a horizontal line, it means the object is at rest. And then when it is a straight line, it means it is a constant speed. So for object A, first it was at rest and then it moved at a constant speed. What about object B? Object B, a distance time graph, which is a straight line. So it means it is a constant speed because it's a straight line. And when it is a horizontal line, it means the object is stationary or object is at rest. So first the object was moving at a constant speed, then the object stopped. What about C? First it is a straight line. So when it is a straight line, what we can say? We can say it is a constant speed. And then the angle is increasing. So we can say that the speed is increasing or object is accelerating. So that is what we have to find: an object move at a constant speed, like a straight line is there or a constant speed, and then it begins to accelerate. What about D? Why D is not right answer? Because for D, the speed is increasing continuously for an object, or object is accelerating continuously. Like it was not moving at a constant speed, it just accelerates. So option C is the right answer. Is it clear, this one?
Yes, sir, clear.
Okay. The next one, what is the unit of acceleration?
Meter
So,
per second square.
so unit of acceleration is meter per second square. Then the graph shows a distance traveled by a vehicle changes with the time. So because from P to Q, a distance time graph, it is a straight line. So we can say whenever it's a straight line, we can say it is a constant speed. Then it's a horizontal line, so object is stop at rest, or speed is zero, you can also say. Because when it is at rest, speed is object is not moving or speed is zero. And then again, there will be a constant speed. But what is the difference between the speed of P and Q? Both are constant speed, P and Q, and R and S. Both are constant speed, but what is the difference? Because they are different angles. PQQ is much steeper as compared to R and S. So it means this will be a higher constant speed as compared to R and S. So first, from P to Q, it's a constant speed. Then Q to R, the speed is zero, object is stationary. And then from R to S, the speed is also constant. So A will be the right answer. A runner runs 300 meters with an average speed of 3 meters per second. Then she runs another 300 meters with an average speed of 6 meters per second. What is the average speed for total 600 meters? So how we can work out an average speed? If you want to work out an average speed of an object, average speed is the total distance divided by total time. So what is the total distance? First, a runner runs 300 meters. Then she runs another 300 meters. So total distance is 600. But what about the total time interval? She completed the first part of the lap or the run in with a speed of 3 meters per second, and the last part with a 6 meters per second. So first we'll find how much time it will take to run the first part. We have the formula. You can remember from this triangle that speed is equals to distance divided by time. So if we need the time, it will be distance divided by speed. So distance is 300 and the speed is 3. So 300 divided by 3. So first part, it will take 100 seconds. The second part, it will be 300 divided by 6, which is equals to 50 seconds. So how much time it took to run the total 600 meter? That is 150 seconds. So 600 divided by 150, that's equal to 4 meter per second. So B will be the right answer. Is it clear, this question? Another question about the average speed, that a runner runs 400 meter with an average speed of 4. She runs 200 meter in 40 seconds. How long she will take to run the remaining 200? So a runner runs 400 meter. 400 meter is the total distance. And the first 200 meters, she completed in 40 seconds. Like the time, that is 40 seconds. We want to find how much time she will take to complete the remaining 200 meters. That's the question. So first, what we will do, we will find, and the average speed for the whole journey is given. The average speed is 4 meter per second. So first we'll find how much time she will take to run this complete. So how we'll find that? We have the formula, time is distance divided by speed. So distance is total 400 and average, her average speed was 4. So 400 divided by 4, so means she will take 100 seconds. So she will take 100 seconds total to run this race. If first 200 meters she is taking 40 seconds, so what will happen? The remaining she will take 60 seconds, because total time she took 100 seconds. So first 200 meters in 40 seconds, then remaining 200 meters in 60 seconds. That's why A will be the right answer. Is it clear, discussion?
Yes, sir.
A car travel along a route P, Q, R, S, and T in 30 minutes. What is the average speed of the car? How we can work out the average speed? What is the formula for the average speed?
Total distance over the
The average speed is equals to total distance over total time. So what is the total distance? 10 plus 5 plus 10 plus 5. So average speed is equals to 30 kilometer. Oh, sorry, the total distance is 30. And how much time? Because all the options are given in meter per kilometer per hour. So we have to convert the 30 minutes into hour. So it should be 0.5. So 30 divided by 0.5, which is equals to 60 kilometer per hour. A car travel 100 kilometer and it take 2 hours. The highest speed and the highest, like a car travel 100 kilometers. This 100 kilometers is the total length of the journey, like the distance covered by the car. And during the journey, at any point, it was having the highest speed. At any point, it might highest speed of 80 and the lowest speed is 40. And the total journey is 2 hours. So they are saying what is the average speed. So for average speed, we don't bother about what is the highest speed and what is the lowest speed. When we work out the average speed is the total distance divided by total time. So total distance is 100 kilometer and the total time is 2 hours. So that's why it is 50 kilometer per hour. So don't bother about the highest, the maximum, the minimum speed. It's just always the same formula, that total distance over total time. Here we have to sketch a graph without the values. A bus travel at a constant speed. Then it stop for a short time. Then it travel at a higher constant speed. So distance time graph, how we represent a constant speed? We represent by a straight line. So bus is traveling at a constant speed. So this is showing that the bus travel at a constant speed. Then it stop for a short time. So because for a distance time graph, if an object stops, it will be a horizontal line. And they mention it's a short time, so you cannot draw like it's only a shorter length line, shows that it stopped for some time. And then it travel at a constant speed, but a higher constant speed. So what we'll do, we'll draw another straight line, but a steeper compared to the first one. Like if this part A, B, and C, A is representing a constant speed, B is representing stationary object, C is representing a constant speed. But what is the difference between them? The difference is C is much higher constant speed than A. Is it clear, this one?
Sir, if the car starts to move backward, will the line also go down?
If a car start to move backward, Ammar, then this should not be a distance time graph. This should be a displacement time graph. And then it depends whether it is moving at a constant, like moving, coming back with a constant speed, or coming accelerating or decelerating. But the thing is, if it should be a displacement time graph, not the distance time graph. Displacement time graph, because for distance is a scalar quantity, so the direct change in direction does not matter. Like example, if I say a car was moving towards right, so it traveled 3 meters and then take a U-turn and travel 1 meter. So when I make a distance time graph, this is not a negative distance, it is also a positive. But in a displacement, if it moved towards right, it is plus 3 meter, and it returned back, so it will be minus 1 meter. So because of displacement, the direction matter. Distance direction does not matter. So it will continue to increase, like whether it is accelerating, decelerating. So we never make it the decreasing distance. It can be displacement, but not distance. Is it clear?
Yes, sir. Thank you.
Then over the length of a 100-meter section, the time recorded was 1.85 second. Calculate the average speed. So just to calculate an average speed, the total distance divided by total time. So it will be 100 divided by 1.85. So 100 meter divided by 1.85. So what's the average speed?
54.
54. So 54.1, or we can also say 54 unit meter per second. Then what is meant by deceleration? The term deceleration means decrease in speed. So when the object speed decreases, we call that as a deceleration. Decrease in speed is look, if you say like some of the definition which students sent, I want to do one correction. Like if you are saying decrease in change in speed, that is not deceleration. If I use this phrase, if I say decrease in change in speed, change of speed, this is not called deceleration. This is called decreasing acceleration. There is a big difference between decreasing acceleration and deceleration. What is the meaning of decreasing acceleration? Decreasing acceleration means the change in the speed is decreasing, but not the speed itself. Like example, say a car was moving at 10 meter per second, then it moved at a 50 meter per second, then it moved at 80 meter per second, then it moved at 90 meter per second. So when you check the change in the speed, that is, this is 40 here. If you see a negative change in speed, yeah, that is fine. Or simple definition, decrease in speed. Here, what is the change here? 30. Here, what is the change? 10. So you can see the value of the speed, the value of the acceleration is decreasing. So this is decreasing acceleration, but not deceleration. We don't say this as a deceleration. Deceleration, this is a decreasing acceleration, but not deceleration. Deceleration is a term which we use for decreasing the speed. When the object speed decrease, we call deceleration. Say an object was moving at 100 meter per second, then turn out to be 70 meter per second, then turn out to be 50 meter per second, then turn out to be 10 meter per second. So the speed is decreasing. So we call that as a deceleration. So there is a difference between a deceleration and decreasing acceleration. Decreasing acceleration means that the speed is increasing, but the change is decreasing. Where deceleration means the speed is also decreasing. The speed of a truck increases from rest to 12 meters per second in 30 seconds. Calculate the distance traveled by the truck during this time. Look, whenever object two speeds are given, like object was initially at rest, so what was the speed? 0. And it was accelerating, it reaches a speed of 12, it reaches a speed of 12 meters per second. And the time it took, that's equal to 30 seconds. When we use the formula, like we have the formula, speed is distance over time. So distance is speed multiplied by time. But this formula is only valid, or you can use this formula if the speed is constant. This is only valid if the speed of an object is constant or speed is not changing. But now, when the speed is changing, we cannot use this form. Like we directly don't substitute the value of a speed. We take an average speed of the two values. So first speed was 0 because the object was stationary, and the second speed is 12. So what will be the average speed as the object speed is changing? So distance is speed multiplied by time. But this time, when we substitute the value of a speed, we don't substitute 12 here, as the speed is changing from 0 to 12. So from 0 to 12, what will be the average of 0 to 12? What is the central number from 0 to 12? So we'll substitute 6.
6.
The average will be 6 and the time is equals to 30. So it is 180. Distance is there, so it will be 180 meter. So it depends on the question. There are two ways. If an object is moving at a constant speed, for example, if I say there is an object which was moving at a speed of 30 meters per second, and it continued to move with a speed of 30 meters per second for 4 seconds. And the question is calculate a distance. So how to calculate a distance for this type of question? Distance speed multiplied by time. So speed is 30 and the time is 4. So that is equals to 120 and the unit will be meter. But what if the object is moving and it is continuously changing the speed? Like it started with, the object started with a speed of say 4 meters per second and it reaches a speed of 20 meters per second. What is the average? How to take, and say it continue for 10 seconds. So what is the average? Because the object speed is not constant, it is changing. So what is the average here of these two numbers? It will be 4 plus 20 divided by 2, because that's how we take an average of the two numbers. So it will be 24 divided by 2. So average will be how much? It will be 12. So what we substitute when we calculate a distance, we don't substitute 4, we don't substitute 20, we'll substitute 12. And 12 multiplied by 10, so we'll get 120 meter. So the idea is that when the object speed is changing throughout the motion, we take the average of the two values of the speed and then substitute in the value of speed and multiplied by total time. But if an object speed is not changing, then the value of the speed or multiplied by time, we get the distance. Is it clear, the two examples?
Yes, sir.
Anyone having a doubt here? Sarah, Nourish?
No, sir.
Okay. So as you can see in this question, what happened? The speed of a truck increases from rest to 12. So speed is not same, it's changing. So what was the start? 0. What is the final? 12. And how much time is there? It was taking 30 seconds. So because the speed is changing continuously, so average of 0 and 12 is actually 6. So we substitute the formula distance is speed multiplied by time. So speed is equals to 6 here and multiply by time 30. So we get 180 and the unit will be meter. Then a boat is moving at a constant speed. Sketch a distance time graph for the boat. Whenever object move at a constant speed, so distance time graph, it will be a straight line. So this was exercise 1.